What was discovered at the cosmic frontier by the new space telescope, and why are scientists so enthused about it? Check it out. In 1916, Albert Einstein applied his new theory of gravity, which replaced Newton's, to the universe's largest source of gravitational mass. This work was done in Berlin during the height of World War I. Einstein's theory demonstrated that the cosmos cannot be motionless and must be moving, either expanding or contracting. Actually, American astronomer Edwin Hubble observed galaxies breaking apart like cosmic shrapnel in 1929 after a massive explosion called the Big Bang. This is essentially what we mean when we claim that the expansion of the universe is caused by the separation of galaxies. We'd need to be far enough away with our telescopes to see it in the latter case, but Einstein's theory could easily describe as a universe that bends back on itself like a higher dimensional version of a ball surface with no edge. Galaxies that are similar to opposite cosmic poles. Others may argue that the cosmos has an advantage because it was created 13.82 billion years ago during the Big Bang. As a result, we can only see galaxies whose lights haven't traveled more than 13.82 billion light years to reach us. These galaxies are in the observable universe, a sphere of space centered on the Earth. Because the cosmos expanded significantly faster than the speed of light during its first split, it is actually 92 billion light years across. The observable cosmos, like the oceans, has a cosmic horizon that surrounds it on its second instant of existence. We know there are an endless number of galaxies beyond the cosmic horizon. Their light has simply not reached us yet. Can the JWST see the edge of the cosmos after the building and launch of a $10 billion space telescope? All you can see if your eyes can detect all the radiation around you is the visible cosmos. The cosmic microwave background, which occurred around 13.8 billion years ago, when the universe was opaque like a dense fog, is the farthest unseen light humans can see. Hence, the observable cosmos has a limit. Although some researchers believe that certain gravitational waves and neutrinos that surround us came from even farther away, the technology is not yet developed to back up this theory. Cosmologists assert that the observable universe is only a small part of a larger reality, or that the same physics holds true for a more rigorous justification. One of the galaxies found by researchers to be close to the universe's outermost reaches is Abell 2744Y1. There are many reasons why this galaxy is unique. It takes 13 billion years for the light from Abell 2744Y1 to reach us. The universe is 13.8 billion years old. In case you forgot, it's an intriguing feature that Abell 2744Y1 is visible at such a young age of roughly 650 million years. This holds true for all far-off objects in space, given how long it has taken for their light to get to us here on Earth. Chandra is being used by scientists to collect more data using X-ray wavelets. Astronomers can study galaxies up to 100 times farther away than they could have by themselves by combining the data from these three space telescopes. The Hubble Space Telescope was employed as the initial research tool by astronomers from La Laguna University and Spain's Instituto de Astrofísica de Canarias, or IAC, which was successful in locating the questioned galaxy. The distance between the item and its position is then calculated using Spitzer's tools. The researchers also noticed Abell 2744Y1 and gravitational lensing, a technique that magnifies images of distant galaxies by using nearby galaxies to bend light like a magnifying glass. Since Albert Einstein predicted its use as a natural telescope to study the farthest objects in the universe, how big is this galaxy? Around 2,300 light-years across, Abell 2744Y1 is about 50 times smaller than the Milky Way galaxy that encircles our own. Its star formation rate is 10 times faster than that of the Milky Way, a characteristic of early cosmos galaxies, more than compensating for its small size. If you're wondering how the name came about, it comes from the fact that the supernova was found by the Dark Energy Survey, a research project intended to learn more about the enigmatic force thought to be responsible for how the universe is expanding and speeding up. Supernova have produced some of the biggest explosions ever recorded. Imagine an atomic weapon that explodes much louder. They depict the star's final valiant attempt before death. These stars dwarf the sun by at least a factor of 5. When two stars collide, a supernova can occur because supernovas are rare, with only 2 or 3 occurring in a century. It is usually amazing when this happens. DES 16C2NM was discovered in 2016, and scientists determined that it's an extremely rare supernova. It's almost like a turbocharged version of what we call a supernova. This discovery was made by an international team of astronomers after determining that the explosion occurred around 10.5 billion years ago. This means that the light from the explosion has traveled to us for more than 3/4 of the universe's history. And that's all for this video. If you liked the video, don't forget to like, share, and subscribe. Bye.